So I'm going to do a demonstration of a pendulum. I have here a ball at the bottom of a string. We'll consider this a massless string. I got a volunteer here who's going to help me with this. If I lift this ball up, I need my measuring tape. From this, we can make the word problem, actually the word problem that's on the board right here. If I lift this up, and I want to know how high this is in order to make calculations, when you're out in the workforce in the field, you're going to have to make your own measurements. Hence the reason you took metrology. I have here a measuring tape, and I'm going to measure to my chin, right here. To my chin, and it's what do we got here? 61 inches or 55 centimeters. And we'll go 55 centimeters. 61 inches about here. When I let it go at the bottom, try and keep that height. The height from the bottom to the floor is, so we can do calculations of kinetic and potential energies. That is 32 inches or 32, looks like about 81 and a half centimeters down there. So we can make those measurements. With those measurements, we could use our calculations, our equations. I'm going to put this up here, and we're talking energies now. I'm giving it potential energy by raising it up here. You can calculate that potential energy because we just made the measurements. The mass of the ball, by the way, I weighed it, is 168 grams. So you have everything you need for potential energy, mgh. Kinetic energy, we can calculate the velocities from that. So I've got it right now, it has all potential energy, zero kinetic energy, because it's not moving. If I let it go, and if there was no resistance whatsoever, it's going to come back and hit me on the chin. So you can't hold on to that steady. Don't swing it, otherwise it will hit me on the chin. Hang on, here we go. Where'd it go? There it is. So it didn't come back, I'll do it again. Just try to get horizontal, trying to get it go straight horizontally. So I'm starting up here. And you can see it didn't quite make it back to me. And this will bring us back to our final question today. So doing all of this and a simple measuring tape, a little bit of calculations, we can calculate what we need to know, in particular the velocity of this at the bottom. What is its maximum velocity as it let go? What is maximum velocity when it reaches the bottom? And that is the basis of our word problem. Thank you.